Good afternoon and welcome to MC4 Software's webinar on how to create a radiant heating and cooling system using the non-graphical input method. We can first go to the locations icon under the loads calculation tab and project settings panel, which is here, left click. And under the general and climatic data window, we can click on the database button, where a locations list window will open. We can select our nation. As you can see, we have a large selection of nations to choose from. We'll type in U for USA. And for state, we have all 50 states to choose from, including the District of Columbia. We'll choose the District of Columbia, and for our demonstration purposes, we'll choose the location of Ronald Reagan International Airport. As you can see on the right-hand side, under the General Data tab, under Weather Data, we have our location, nation, our state, latitude, longitude, and altitude. For our temperatures, because of our location that has been already selected, it has preloaded the external T in Fahrenheit, summer dry bulb and wet bulb temperatures, our daily thermal excursion, as well as our soil temperature in Fahrenheit. If I come to our weather data tab, you can see that we have the months of the year as well as the hours of the day with the ASHRAE values filled in. If I click apply, OK, we come back to our general and climatic data window where our location has already been loaded, which also has our sky clearance, our solar reflectance of foreground surface, our altitude above sea level, and then for our winter and summer conditions, we have our dry and wet bulb temperatures in Fahrenheit, as well as our relative humidity percentage. I will select End, and now I can go to our database panel under Loads Calculation, and I can select our database for our structures, which our project tab currently has nothing in it. So I can go to our database MC4 tab. And as you can see, I'll put this in alphabetical order. I can see that we have a large selection of elements to choose from for our structures. I can choose an 8-inch block R19 wall. As you can see below, we have the I represents interior and E represents exterior of this is how our wall will look. I can select in project. I can also come down and I'll select our ceiling, in this case the gypsum joist R38 attic. I can select. I can also right click and select in project as well. If I want to choose more than one element, I can highlight one by left clicking, for instance the plywood 2x10 joist R19 internal, and then hit the control or hold down the control key and select internal wall 2x6 metal R-0.92 and then select in project. If I come to back to our project tab, you can see that we have all 4 elements now inserted into our project tab. For instance, with the 8-inch block R19, under the General Data tab, we have it broken down into 2 separate categories, such as General Settings and General Calculation Settings. We can use our default selection, or we can actually modify it if we would like, such as the type of element. We can choose instead of internal wall, we'll choose external wall. Also, for our colors, if we would like, we can choose different colors such as red, but we'll use the default cyan. If I come to our Layers Structures tab, I'll extend these so we can read. We have broken down into our code, description, our thickness, and our TM. For instance, for our 8-inch block wall, it is composed of a 2x6 standard 16 OC R19 bat and a center block 8-inch hollow. If I'd like to add to our 8-inch block wall, for instance, I can click and drag our plywood into our level here. And as you can see on the left-hand side, our layer by layer structure from inside to outside. So inside being our 2x6 standard and our outside being our plywood. You can also see over here that our plywood is our thin piece of line on our exterior. If I would like to make it into the middle, I simply left click on this arrow here, and as you can see, it has been moved in. Or if I want it on the inside, left click one last time, and it's on the inside. If I like to actually delete a certain element, I can highlight it and click the delete. The MC4 database warning window comes up asking if I'd like to delete it. I'll confirm, clicking yes. In the project tab, if we delete an object, we can do so by selecting this button here. But if we're in our database, for instance, our database MC4, and we delete a element here, we will not be able to retrieve that element for further use. It will permanently be deleted from our database. So at this point, we have our 4 elements, and we'll click apply and OK. And we now will need to create a level or a floor level, which we can do so in our project's setting panel, which is here, or we can come down to our building step-by-step side panel and select level list. As you can see, we have nothing in our project tab, but we can select new, and we can create a new level name. We'll call this main. And since this is a non-graphical input demonstration, we will enable the box labeled non-graphical input. We'll select OK, and as you can see, we now have in our project our main with our net height, and over here under our level characteristics, our non-graphical input box is enabled. If we would like, we have the option to increase or decrease our net height. We'll leave it at 9 feet. For our ceiling, we need to select a structure, and since we selected a structure in our structures database window a moment ago, we'll select our ceiling, which is Egyptian joist R38 attic, by double clicking. And for our exposure, we need to select an exposure which can be anything but calculated. So in this case, we'll choose the condition space and get rid of calculated. And then we'll do the same for our floor. We'll choose the plywood, and our exposure will come to our database MC4, and instead of calculated, this time we'll choose slab on grade with an R10 insulation. For our RFH data, we'll choose a floor covering, and if we go to our database MC4 tab, you can see that we have different types of carpet, tiles, limestone, ceramics, hardwood floors, etc. We'll choose the hardwood oak 3/8 inch. And for our radiant system, we'll go to our database MC4 tab, and we also will use our filter command, and we'll use a Viega filter. And now we have all of our Viega radiant systems to choose from. We'll choose the slab on below grade 12 inch, half-inch Viega PEX barrier by double clicking. And for our fixed occupied spacing, we have the options of choosing anywhere from 2 to 18 inches. We'll choose 6, enter. And for our fixed perimeter zone spacing, we'll have the same option. We'll choose 6 inches. If we come down to our options tab, you can see that it's labeled elevations, and we have the option to increase our building elevation or decrease our building elevation. And the same goes for our ground elevation as well. If we go to our elevations tab, you can see that this is our level here and is broken down into certain dimensions. We'll select apply and OK. And now we have our level created. As it can be seen in our level tab over here, under projects we have our main, which is turned on, and it is our active layer, which is confirmed by this blue arrow. We can now go and insert an XREF drawing or DWG drawing by going to our XREF panel and selecting this icon here labeled DWG, or we can come down to our building step-by-step under graphical input and select insert XREF. I can select first floor DWG. A window will open here in a moment, and I will designate where I would like it in our drawing by putting in X value as well as a Y value. I'll confirm by clicking OK. And we now have our drawing inserted in. To confirm our units of measure, I can come to our unit of measure icon here under the project settings panel. I'll left click, and display measuring unit window will open, and we have the option of choosing imperial units or international standard metric. Well, since this is in the United States, we'll choose the imperial units. We'll come down to scale, and as you can see, our description of scale, our unit of measure, we have different options to choose from, either feet, inches, miles, yards, etc. We'll choose inches. Our accuracy, if I left click here, we have different forms of accuracy that we can choose from. We'll choose to the nearest hundredth. And finally, rounding. We can round to the nearest 0, 5, 10, 50, or 100. We'll click apply, OK. And we can finally scale our drawing with the scale factor icon here, or underneath the graphical input, we can choose the icon here labeled scale factor. We'll come to a known dimension, this 2 feet or 24 inches, and we'll type in our dimension, and I'll confirm it. And now we have successfully dimensioned or scaled our drawing. So if I come to our layer manager, I can simply turn off our 2 layers here to make it more aesthetically pleasing. And we are ready now to go and create some building units, which can be done so under the building step-by-step, clicking on the building units, or coming up and clicking on zone to set the internal design conditions. As you can see, we have our units zones list. We need to first add a unit, so I'll click add unit. For the description, I'll label this unit-1 we have a pre-coded view numbering 1. Properties, we can enter any information we would like, and we'll use the default for the exposure between units. If I come to the Radiant Systems tab, we need to select a manufacturer. In this case, we'll choose Viega. 2 additional tabs appear below the Radiant Systems tab, as well as the Building tab. For the Radiant Systems tab, for the design criteria, we have 2 options to choose from. We'll use the default, which is the heat-based sizing and cooling verification. We also have 2 other systems, the predominant and the secondary systems, to choose from. The predominant, which is floor for this case, but we also have the option to choose it as a wall or a ceiling. But for demonstration purposes, we'll use floor with the system type as embedded. For our secondary system, we have the only option is wall. And we'll use the embedded for the type of system. Since we have our unit created, we'll add a zone by clicking add zone. And for the description, we'll just label this as zone 1. We'll need to select a type of zone, which is air conditioned, which is heating and cooling, heated, which is only heated, or not conditioned at all. We'll choose the air conditioned. And because of our location, we have our temperatures and relative humidity already preloaded. For our number of air changes, if we would like, we do have the option of manually altering the values by just simply typing them in. For instance, in this case, for the number of air changes, we'll type in for the winter 0.3 and for the summer 0.3. We can now go to the Systems Data tab, and we need to select a type of system. In this case, we'll choose a radiant heating system. Below, we have our Systems Data type for the air movement index. we have several different choices to choose. We'll use the default, which is the system with fan coils or induction, or in any case with air movement, less than or equal to 8 volume per hour. The working schedule code we'll need to choose from our down arrow for both winter and summer. As you can see in our project, we have nothing selected, so we'll go to our database MC4, and we have the option of choosing always on or warehouse heating cooling. We'll choose always on, and we'll do the same for the summer. Our final tab is internal loads, and again, our information has already been preloaded, but for people, lighting, and appliances, we need to select a time profile percentage. For people, we can come down to the people, hotel, guest room. Lighting, we'll do the same, but for lights. And for appliances, we do have appliances for office, but we can also choose cooling only. We'll select apply and OK. And now we have successfully loaded our internal design conditions. Now after this, we have our top of the screen is designated as north, as the program has already preloaded into its memory. But if we'd like to change where the north is, we can come to our project settings panel, select the icon north, and simply left click for its position, and then we can do another left click for its angle, or simply type in an angle. In this case, we'll type in 45 and enter, and now we have designated the drawing that 45-degree angle north is in this direction. We can now move on to our radiant tab. As you can see, we have a whole new selection of icons to choose from. And the first, we'll go to our general info panel and choose a pipe project. As you can see, the pipe project list appears, and we have nothing in our project, so we'll select new. And for our new piping system, we'll call this Radiant NGI for non-graphical input. For our system type, we have different systems to choose from, such as thermal, plumbing, gas, fire protection systems, double phase fluid, or mechanical room. We'll choose thermal. And for our supply and return system fluids, we'll go to our database MC4 tab, and we will select a water 40 degrees Celsius, which is equivalent to 140 degrees Fahrenheit. We'll do the same for the return. And then we also have the option if we would like to make this a schematic drawing or a non-schematic drawing. In this case, we'll make this a schematic drawing, and we'll select OK. As you can see, we have our description, our system type, which is thermal, and schematic, with our fluids under our design data section, with our spacing in inches, which is 3.94. If we would like, we could fix this spacing by simply enabling the box, or enabling the box and letting the software create its own spacing. We also have the option to enable the box here to use pipe bypass. We also have the source temperature in Fahrenheit, as well as, if I move this over some, insulation bill of material calculation. We also have two additional tabs below, which is fan coils and radiators. Under fan coils, we have broken down into different sections, such as the fan coils and units heaters. We have a type of terminal, which is a 2-pipe, but we can also choose 4-pipe. We also have different types of calculations to choose from. We'll use the default, as well as fan speed, as well as we can select a water flow rate, air movement, and maximum delta P. We also have safety increments, minimum delta T's, intake air, entering water, and primary air contribution. The values are already preloaded because of our location, so we can have these values modified if we would like by simply using the up and or down arrows, but we'll use the default for our demonstration. We also go to our radiators tab, and you can see that we have our radiators calculation criteria. Once again, these numbers have been preloaded because of our location, and we will use these as our default. I can now simply click Apply and OK. And if I come to our Systems tab over here, you can see that our Systems tab, we now have a Radiant NGI, and the symbol determines that it's thermal, and with the blue arrow means that it is active. We'll come back to our level. Now that we have our pipe project confirmed, we can now create our ray areas, which we can do so by coming to our ray area panel, and we have the option of either drawing a ray area manually or converting a line into a ray area. If I convert a line into a ray area, I'll select this icon, and I have the circuit area type, which I can either choose allowed or forbidden. We'll use the default allowed. We also have the section here, fixed Z coordinate, which we have options to choose from. We'll use the default by the floor. We have our Z, elevation in feet, our distance from circuits, our floor type, which is occupied, perimeter, or imposed. At this point, we'll use occupied. And then we have our distance from perimeter, our system, as well as pipe spacing in inches. Since this is occupied, I can simply left click on the inside or the internal wall, and you can see that a green arrow line has been drawn, which is our ray area. I can also do this again, and if I'd like, I can actually take this grip and extend it. There's also another option. If I choose to draw ray area by manually, I can simply left click, and it's like drawing a line where I'll come here, and since this is the exterior, I will change this from floor type occupied to floor type perimeter. I'll left click, and left click. As you can see too, by choosing perimeter, the line is now dashed, whereas as occupied, the line is a solid line. So if I go ahead and use the draw ray area manually, I'll continue drawing the perimeter. Oops. I overextended it, so I can take the grip, I can shrink it, and then resume drawing the perimeter. Now, since this is going to be the inside, I will change it from perimeter to occupied. And I'll continue doing each room one at a time using the manual ray area. And now coming over to our corridor area, I'll just simply, again, using our manual, and now we're going to our exterior wall, so I switch it to perimeter, and I'll enter, come back, still perimeter, I'll use the outside of the wall, coming back to the interior, switch it to occupied, and coming to our last room, our family room, we got 2 lines for occupied and our final 2 lines, which will be perimeter. Now that I have, if I come down here, we have our rooms created by our ray areas. If I come up to our ray area, we can now tag the ray area and assign the property for each room. If I left click, as you can see that we have different information in our commands Windows sidebar to choose from. We will first go ahead and tag the room which is labeled kitchen. We do have a description kitchen. We can choose the room to be automatic. We got the room type, which is normal. We need to select a zone in order to confirm this, so we'll select zone 1, which we did so earlier in our building units. And we need to choose a type of load, which could be either BTUs per hour or BTUs per hour feet squared. We'll choose BTUs per hour. And then we also need to put in a heat loss, which in this case we'll type in 35, and for our cooling related request we'll type in 35. If these values here are left 0, you will receive an error. So these two, for our heat loss and cooling load request, they need to actually have a value in order to confirm this, this command. So by being kitchen, I can now simply left click. As you can see that it says no closed right area. We have a warning symbol down here highlighted in yellow. If I click here and left click here, it was basically I did not close the right area completely. So with its new closure, we do have now a right area label created. As you can see, we have our code, which is one kitchen, our room area, our covering, which is our flooring, which is a hardwood 3/8-inch oak floor, our exposure, which is a slab on below grade 12-inch, half-inch Viega PEX barrier, and finally our radiant area, which is 369.14 square feet. Now if I continue to do the rest of the rooms, since this one's already our kitchen, I need to come back and go to our area description and choose corridor. Make sure, yes. And then I can choose half bathroom. I can scroll down and choose our closet. Got a dining room, our entryway, and finally our family room. Now that we have our right area labels drawn, signifying each room, I just move these out so it's a little bit easier to see. I can also zoom in, and since this is our kitchen area, we will not want to have our circuits drawn in our cabinetry area where our sink and stove and oven are going to be located. So I can come back to our draw right area manually, left click. This is going to be perimeter. So I'll left click on the right area line, and then just like drawing a line, I am going to exclude the cabinetry area, and then finally come back and perpendicular to our right area line. As you can see, the right area line has created another right area line over here, and when I go ahead and draw in the circuits, it will exclude our cabinetry area here and only put the circuits in this area. We can also do the same for our stairwell, where we just want to exclude putting the circuits on the stairs. So I'll come in here and then go into our stairwell a little on the landing and simply enter. And once again, when I insert the circuits, they'll be in this area, but it be excluded in the actual stairwell itself. Now I can go ahead and come to our zoning panel and insert a manifold. By clicking the icon, we have our manifold library, and under project we have currently nothing in our project tab, so we can go to our database MC4 tab, select our manufacturer. We'll just type in Viega LLC, and we can use it to be filtered out where all of our Viega manifolds are listed. We'll choose the manifold shutoff/balancing and use the in project button. click Project, we have our manifold already inserted. Move this out, and then we have our description, our manifold type, which is hydronic system, our diameter class, our manufacturer, long description, and abbreviation. If we go to our hydronic or plumbing distribution manifold tab, you can see, if I extend this out some, you can read it better. We have it broken down into our drawing values, DWG block, connections, connection valves, and finally our manifold cabinet. We can use our down arrows to select different values for each, or just use our default. In this case, we'll just use our default, and we'll select Apply and OK. With our manifolds being drawn, we also have the option for our distribution line to be either supply or return. In this case, we'll use supply. We'll need to choose our type, which is our shutoff/bouncing manifold. We'll double click. We have our number of exits, which we can use our up or down arrows to determine how many number of exits there are, or we can simply just type in a number, in this case 4. For our height from the ground in feet, we can just simply type in 3 feet, or again use our up and down arrows. For our project information, we can use our default information, or in this case for pre-code, we can switch M for manifold. Now I can zoom in, and we'll put one manifold between our closet and our bathroom. Our first left click is for position, and our second left click is for rotation. With our label, again, 2 clicks will insert it. And as you can see, we have our label designating our manifold, which has 1, 2, 3, 4 exits. We'll do this one more time. We'll insert another manifold. We'll do this down here by the entry. And again, this time we'll rotate it going vertical. And we'll put our label over here, again with 4 exits. Now, since we have our manifolds entered into our drawing, we need to associate the manifolds with each room, which can be done so by going to our zoning panel and going to our room arrow manifold button. So if I click on the manifold itself, you can see a line will be drawn, and we'll click on our endpoint of our right area label. I can right click or enter, and as you can see, it has been highlighted designating that this room here is associated with the M1 manifold. So if I continue, select the manifold, select the label, and it's been highlighted. I also have the option, instead of selecting the actual manifold, I can select the label itself, and then again continuing on and selecting each room. I come down here to the M2 manifold. Actually, I'll do the corridor first. Select the label and our final room, which is our family room. As you can see, we have all of our rooms being associated with each manifold. Our M1 manifold has 4 rooms, as designated also by the magenta lines, and our M2 manifold has 3 rooms that it's associated with. If I come to our radiant heating system tab on the side, if I turn off disable the highlighted areas box, you can see that all the shaded areas are turned off. If I enable the box, they reappear. So I'll just turn them off for the time being, and I'll zoom in a little. And we are ready for our calculation, which can be done so by going to our zoning panel and our design temp icon. As you can see, we have our M1 and M2. And if I click on one, we have number 5, closet, which is also designated down here in a graphical area. And as you see, each room is broken down into area, pipe spacing for occupied, pipe spacing for perimeter, number of circuits, room load, BTUs per hour, load density, BTUs per hour feet squared, residual load for BTUs per hour, our delta T in Fahrenheit, our floor temperature in Fahrenheit. I'll scroll over. Our flow rate for gallons per minute, our length medium in feet, tails, and finally our delta P medium. We would like to have our residual load close to 0 as possible for our closet. In this case, it's around 47, and I can do so by lowering or raising the temperature of the floor, or the design temperature range. I can raise or lower, which will make the residual load go either up or down. So if I scroll down, again, closet 25, we can also type in a number. We'll type in 90 degrees, and that's close to 0, so 14.6. As you can also see for kitchen, it is highlighted in blue, which this is our room information. We got our room, which is our calculation type, our heat load request, lower space winter temperature, and so forth. If I choose the down arrow, you got 2 more options. These are its ray areas, as you can see, ray area, which is highlighted in green. And also, will be the section that will be excluded for the circuits. And as you can see, you got your colors for your return and supply pipes, as well as your line types for return and supply, and so forth. If we click OK, we have now calculated our design temp, and we are now ready to insert our circuits, which can be done so by going to our circuits drawing and going to our live serpentine icon. And we have our floor type. We will choose it as occupied. And if I zoom in for our kitchen, as you can see, our circuits are being previewed here, and as you can also see, they are being excluded from our cabinetry area. If I type T for turn, you can see that I am turning the circuits in different directions that I would like. I will choose this one. And also, if I zoom in a little bit down here, you can see that there's an arrow on the left-hand side of the circuits. If I type D for direction, they have now switched to the right side. So you have the option of changing the direction of your circuits. I'll choose the left, and I'll confirm by left clicking. As you can see, we have our circuits now drawn inside, excluding our cabinetry area. I'll continue to draw in our circuits for each of our rooms. And once again, too, for our corridor area, because I used the icon here of Draw Array Area Manual Drawing, I've excluded the actual stairwell, so they put it into the landing as well as the actual corridor. As you can see, too, before the label for our M1 manifold had a 0 here, which meant there were 0 tails. Now there's the number 4, representing that there's going to be 4 tails that are represented to this M1 manifold. And down here, we now have 3. So we have 1 for the red, 2 for the green, and 3 for the yellow. So we have a granted of 3 tails that will come into our manifold. Since we have 4, I can also highlight our manifold, come to our extended data, and I can, for the number of exits, lower it down to 3, select apply, and now you can see that our manifold has changed from 4 exits to 3. Now I can go ahead and come back to Commands tab. I can insert our tails by clicking our tails icon. And we have occupied with a distance from the circuit of 0.08. And I'll put my cursor on the blue. And now click imposed, and I'll make this a distance of 0 coming into our manifold. Now, as you can see, our tails have been drawn, and coming with a imposed 0 difference in elevate or 0 difference in separation or spacing, it has now put it on the circuit itself going into the manifold. So I can now go ahead and put in more circuits, and I'll left click here. Make this imposed, so again with 0 spacing. Occupied, and now going into our M1 manifold, we'll do the same coming from our kitchen. This time highlighting our red, left click, and again coming imposed, 0 spacing, and our final room, which is our family room. Occupied, come this time to our blue. Okay, now we have our tails drawn into our manifolds, and we are now currently done our drawing of our non-graphical input radiant system, but we'll need to do one more calculation. So we'll come back to our design temp icon. As you can see, we'll go ahead with our closet with the 90-degree design temperature range, and we have the residual load in BTUs per hour, which is 32.4. We have our room load, which is 10.3 for all. Our load density in BTU hours feet squared for our closet is 1.8. And you can also see our other temperatures for our rooms that represent our M2 manifold. So we'll select OK. And now we're ready to print some reports. So we can go to our reports panel and click on our radiant report. We can choose a long or short report. We'll choose short. We can choose our language, which in this case we'll choose English USA, and we'll choose where we would like to save our file. We'll just call this NGI. NGI report, and we'll save this as an RTF file. We'll select OK, and after a few moments a Microsoft Word file will open in an RTF format, and as you can see it's radiant floor heat analysis, and as you will make this larger so you can see better. And we have the option of typing in the information, for instance, type of project, non-graphical input, and we can modify any of this information as need be. The notes, you have the option to putting any notes you would like by typing in the information below. And then we finally come to our radiant report, which is our project details, our project information. We have our type of building, which you can type in residential. We got our total pipe required in feet, our system capacity in gallons, our fluid types, how many manifolds that we have, and finally our total radiant area in squared feet. We also have our heating and cooling, where we have our radiant output BTUs per hour, supplemental heat BTUs per hour, nominal boiler output, along with our flow rate in gallons per minute. Come to our next page, we have our manifold summary, where you can see we have our two different manifolds, M1 and M-2, where it's broken down into our supply temperature degrees Fahrenheit for both heating and cooling, our flow rate for gallons per minute, number of circuits, area covered, our heat loss, our how many rooms are supplied, and as well as our total heat rate, BTUs per hour, and total cooling rate. Excuse me. Furthermore, we have our room details, where we have our rooms designated on the left-hand side, and then it's broken down, which are manifolds, heat load, heat flux, residual heat, and so forth, as you can see here. And that is our, we'll save, and that is our radiant report. And finally, we have our bills of material, which can be found in our reports panel, and we'll select this icon here. We'll need to name this. We'll call this NGI BOM for non-graphical input. Bills of material. We need to choose a price list. From our down arrow, we'll choose Viega. And unassemble fan coils and unassemble radiators will both enable them. This is a thermal project, so for projects to apply, we need to enable the thermal, as well as the Viega Unit-1. We'll select the Create Bill of Materials, and we have our estimated bill of material windows opens. Make this larger. And at this time, these are all the materials that are represented in our project, where we have our description, if they're fixed or not, our types of units, which can be feet, or any of these others by piece, inch, yards, or whatever. Our pricing list measuring unit, in this case, our items are either broken down into feet or by piece, our packaging, and number of elements. As you can see, if I select an item, Viega PEX barrier inch times feet, half inch, 500 feet, we also have other information down here by object type and object characteristics. If I come to our price list tab, you can see that we have it broken down into our code, description, unit of measure, and our price. If we come to our estimated bill of materials, again, we'll extend so we can read all of our information. You can see that it is broken down once again into code, description, our packages, how many are discarded, and our price, with our total quote considering minimum purchase quantity, which the net total is $4,906.55, as well as our estimated bills of materials not considering the minimum purchasable quantity, which is the net total of $4,812.70. If I come back to the bill of materials tab, I can come over to our print icon, click on the down arrow, and I have the option of selecting an RTF or an XLS file to print to. I'll choose an RTF. I have the option of choosing a short and full, or only a short. I'll use the short and full, and then also have the options of choosing to display prices, or VAT or taxes, packages, quantity, and show images. We'll select OK. We need to choose our language. Again, we'll choose English USA. And this time we will choose the name NGI BOM. We'll save, click OK. And as you can see in Microsoft Word in an RTF format, we have our bills of material. Once again, we can have the option to modify or add any information in our section here labeled for type of project, project description, client, and so forth. We also have the option in our second page to include any design notes or comments that are necessary for this particular project. Our next section, you can see it's broken down into chapter, which is our radiant heating system, with a subtotal of $4,906.55 US. You can also see that we have our materials broken down into sections. For instance, our Viega PEX barrier We have our code, our unit of measure, which is feet, our number is 500, our unit price is 89 cents, and our total is 442.68 cents in US dollars, with a long description of what this material is described as. And as you can see, we have the same for each different material. If we come to the end, I'll increase. You can see that our amount without the VAT or without tax is $4,906.55 in US dollars. And since there is no VAT, that is also our total amount. Now if I close, and I can close this, I'll say yes to save. And now we have successfully drawn a radiant and cooling heating system for the non-graphical input method. That concludes our webinar of this.